Hello everyone, I'm Hironobu Wasaki working at Waseda University, National Institute of Informatics, Japan, System Information and X-Motion, all based in Tokyo, Japan. And today I'm very happy to talk about our paper titled Framework and Value-Driven Process for Software Engineering for Business and Society, or in short, SE4BS. So this is a result of extensive joint work between industry and academia. And so we see that many co-authors, including Hagimoto-san, Hamai-san, Seki-san, Inoue-san, Taniguchi-san, Kobayashi-san, Hiranabe-san, and Hanuda-san. Okay, so here's the agenda of my talk. Firstly, I will briefly introduce the background of this project. And after that, I'm going to introduce our vision and concept for making new software engineering in this era. And then I will explain details of framework and process. And finally, I will conclude my talk by introducing some brief case study as well as conclusion and future work. Okay, so here's the background. So digital transformation, or in short, DX, transforms a business model by digital technologies, including IoT, cloud, AI, big data analytics, and social networks. So successful digitalization requires not only technology, but also an understanding of the importance of data, business agility, ecosystem, and autonomous organization. In addition, without careful traceability, software engineering projects can be not based on business and social values. Well, in other words, we often see some misalignment between software systems and business. So the question is, how can we fill the gap between business and social values and software systems? So that's a key research question of this project. So to address these concerns, we propose a method framework and a value-driven process for new software engineering in the era of DX by focusing on business agility and traceability. Here, value-driven means that any artifact and activity can be traced back to values and also validated against values. Okay, so here's steps. Here are steps for building our framework as well as corresponding process. We first focus on the Takumi method, which uses strategy to design activities from a business perspective. So if you are interested about more about Takumi methods, then you can take a look at the document here. Okay. And so we generally follow the Takumi method to organize vision and concepts. And after that, based on the vision and concepts, the most suitable widely used methods, practices, and models, including models defined in the Takumi method, were identified and categorized. Okay, in next slide, I will explain more about our vision and concepts. Okay, then after devising an initial proposal of the set of methods, practices, and models, other proposals were solicited during public participatory workshops last year. So you can see some photos taken at the workshop. So we got many very important feedbacks from workshop participants. So okay, then finally, those determined via consensus to be absolutely necessary to concretize the concept in a variety of situations were kept in the framework and also process. Okay, so here's our vision for building new software engineering. So our vision is that we need to extend the area of study and encompassing software engineering to design a better society and business. To achieve that vision, we set three concepts, okay? Firstly, open. So we need to establish co-creation of software engineering in open community. Okay, second concept is traceable. So we need to have consistent and traceable models from social and business values to systems and software architecture. And finally, value co-creation. So we need to have a creation of future values for society, users, and stakeholders in the form of software. Okay. So to achieve those vision as well as corresponding concepts, we identify various important methods, practices, and also models. And those can be classified by the workings of thought, human thoughts, and minds of humans necessary for business and society. Specifically, Kant, who is most famous philosopher, describes the fundamental workings of human mind as three types: okay, cognitive, affective, and conative. Okay, so cognitive, or in other words, intelligence, is about logical thinking based on perception and intelligence. So actually, most of traditional software engineering methods fall in this category, cognitive, cognitive or logical thinking. Okay. Okay. Then second type is affective, or in other words, emotion. So that it's about emotional and affective process towards others, which applies to design thinking. So this is mainly applicable to a design approach that will be integrated with future software engineering. And finally, third type is conative, or in other words, will. So that's a kind of ethics-based intent and conceptual thinking, which are concepts typically lost in software system development and operation. So based on these, we classify the models, methods, and practices in a framework incorporating business agility. So here's the entire architecture to develop our framework based on such category of human minds, cognitive, 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 and also affective. Okay, and also from design business, from designing business, and then managing business and IT, and also designing IT and system, and finally designing IT and software. Okay. So, well, at the beginning, it's very important to have methods in terms of related to well, cognitive methods. We need to have some will. How we design society, and also how we have good better in business. So we need to have some cognitive methods. And together with affective methods, because affective methods are about handling such as user needs, requirements, and so on. And finally, followed by cognitive methods, right? So that's a kind of a traditional logical method, such as software construction, verification, and so on. So this is the entire architecture to have a value-driven process. Okay, then we mapped concrete methods, practices, and also models onto such entire architecture, from designing business, managing business, and designing IT and system, and finally designing IT and software. So at the beginning, especially at the level of designing business, we need to conduct some stakeholder analysis as well as needs design and also seeds design by making value analysis models and also value design models, and then moving towards managing business and IT by making related models such as business value verification model and also business model verification by drawing business model canvas. And also we need to connect strategies and activities to move to to move to move on to designing IT and system. And in parallel, from the architectural point of view, at the same time, we often have to conduct domain analysis and also analyze and design business process and also together with some business rules. And after that, at the stage of designing ICT and system, yeah, well, of course, we have to some more user interface design, also software system design, right? So for example, by user experience design, and sometimes together with ICT architecture design and evaluation. And then we need to, of course, connect such user experience with ICT, okay, by using such as user story mapping and also large sketch or paper prototyping and so on. And finally, at the stage of designing ICT and software, we conduct some traditional software engineering activities such as software design, software construction, software testing, verification, and also software release. Okay, so this is a big picture of our software engineering framework. Okay, then you might remember that we also classified those activities into three types of human mind workings, such as affective, conative, and cognitive. Okay, and so well, basically, early phases, there are more and more affective and also cognitive methods and activities such as stakeholder analysis and also needs design and also business value verification. Those are more about affective activities. At the same time, well, in parallel, seeds design and also business model verification, those are more about cognitive. And sometimes and somewhat with affective activity. Okay, then of course, finally we need to have some concrete and executable software systems. For that purpose, later and later, we need to have more and more cognitive, in other words, logical methods, such as connecting UX and ICT, and also domain analysis and architecture, and so on. Okay, then based on that framework, we derived a typical value-driven software development process. Okay, so we identified the input and output and dependency relationships among methods, practices, and models driven by values from business and social perspectives, rather than those driven by architecture. So we design an effective process with the following characteristics, including model-based and traceable. So model-based means that we build a consistent process that is verifiable at each stage. So for every activity, a particular aspects of a target are abstracted in a model, and a series of model transformations is visualized by focusing on its inputs as well as output. A second characteristic is traceable. So we built a process that is traceable from stakeholder analysis to software release. So it clearly indicates connections among models or model elements. So by having these characteristics, we ensure that any artifact and activity of the process can be traced back to values and validated against values. So that's why we call our process as model-based value-driven process. So in next few slides, I'm going to show some important steps of the process. But due to the time limitation, I will not explain details. So if you are interested, please take a look at our paper. Okay, so firstly, we need to create values from a stakeholder analysis. So here, firstly, we make a stakeholder model, and then based on that model, we can derive a value analysis model and also value design model. And then by inputting those models, we can derive requirements analysis tree as a requirements model together with corresponding activities. So here you may see that requirements analysis tree consists of strategic requirements, business requirements, ICT requirements, and corresponding activities. And well, in parallel, often we need to verify business realizability. Okay, so for such purpose, we decided to employ a business model canvas. That is, quite well accepted, method and model. Okay, then by inputting business context flow and also value analysis model, we can derive user story mapping, consisting of value descriptions, actions, and also user stories. For example, user stories can be, for example, to increase the desire to purchase by introducing recommendations, blah, blah, blah. So important point is that at any time we can trace back to values, because in user story mapping, here are value descriptions, and these value descriptions are derived from value analysis model. So by having such traceable links, we can always trace back to business values as well as social values. So that's a very important point of our process. Okay, then finally, we need to extract domain model element candidates from user story descriptions, and then we can create a domain model, and also we can identify user interface screens, or in other words, a kind of rough sketch of user interfaces such as screens and so on from user story statements. And finally, we can design a simple or simplified robustness diagram using screens and the domain model. So here is an example of a simplified robustness diagram composed by user story descriptions, UI, user interface descriptions, and also entities. Okay. So for example, let's assume that there are two related user stories, such as to increase the desire to purchase by introducing recommendations, blah, blah, blah. And second user story is to search an item and place in a shopping cart, blah, blah, blah. Okay, so in these descriptions of user stories, we can identify what could be entities and also what could be user interfaces. For example, here in this case, for example, we may decide to have recommended item user interface and also shopping cart user interface. And here, and there are some related entities such as recommended item and also shopping cart and so on. And finally, by connecting all things together, then we can have a simplified but quite useful robustness diagram for further software design and construction. Okay, then last year, this value-driven process was introduced in a software engineering course at Waseda University. So it was a kind of a case study of our framework as well as a typical value-driven process. So there were 3 teams of 4 to 5 students, and they handled various problem domains such as collaborative, video editing, and so on. And we confirmed that students can confirm the traceability from social and also business values to the final software design and architecture model in their own obtained results. Okay, here is one of good results made by students team. And okay, this is an excerpt of extended robustness diagram with user interfaces. So you may see that there are various interesting user interface sketches and together with corresponding or related entities. Well, although mostly written in Japanese, but you may see the image of actually robustness diagram with user interfaces made by students. So like this, we confirm that our process works well for those case studies. And of course, our framework and also process are not the first try for aligning business values and also social values with software systems. So there are plenty of related works, of course. Well, especially we see there are three important related works. Firstly, there are studies capturing user perspectives via a variety of rapid data-driven mechanisms, including the proposal of hypothesis experiment data-driven development proposed by Olson and so on. But also we see that there are few studies have utilized design thinking to incorporate user perspectives and to organize a detailed and concrete process that encompasses stakeholder analysis to final software system release and maintenance. Okay, so in contrast, our framework integrates not only logical and cognitive methods, but also conative methods and also affective methods, including design thinking. So that's our that's the advantage of our framework and process. Okay, but still, of course, our approach is related to those data-driven methodologies. Okay, then the second type is about value-based software engineering. It was originally proposed by Barry Bain in early 2000, and that includes value-based thinking from requirements engineering to design and development and management of software systems. And well, so yeah, so yes, our framework and process can be seen as a kind of extension or instance of such value-based approaches. But the main difference is what kind of values can be addressed more. Okay, so in traditional value-based software engineering approaches, these mostly focus on the cost effectiveness of handling financial values. Well, in contrast, our approach, our framework, and our process can handle not only financial values such as cost effectiveness, but also some other values such as customer values and also customer opportunities, business opportunities, and also social values and so on. So, but still, of course, as I said, our approach is quite related to value-based software engineering approaches. And finally, there are various approaches for business and IT and software strategic alignment, and also related goal-oriented methods, such as GQM plus strategies. And so actually, our approach can be seen as a kind of extension of such alignment approach, but to address more entire connections from business to software. So as a conclusion, we propose a vision and concept of new software engineering for business and society, or in short, SE4BS, that incorporates business agility towards the era of digital transformation, or DX. As a framework, we categorize related methods, practices, and models, and we propose a value-driven process based on the framework. And we also categorize these items by using the mental factors of cognition, affective, and conative. So, of course, there are plenty of future works. Of course, we need to release these results widely to to build an open community. Open is one of our very fundamental concepts. And also we need to apply this process to actual industrial developments to verify and revise its effectiveness. And of course, we do not think that the process introduced today is not we think that the process introduced today is just one of possible effective and efficient processes based on new software engineering frameworks. So in the future, we also think about further various different types of processes, such as a process aligned with more agile process. Okay, so that's it. That is my talk, and so thank you for listening. And also we are very happy to take your questions and comments, and we are very happy to answer your questions and or comments. So thank you very much.